Hey everyone, and welcome. Today, we're taking a journey through one of the most incredible systems in your body, its ultimate filter, the urinary system. It's this amazingly efficient, totally vital network that's working for you every single second. So let's just dive right in.
Okay, let's start with a number it's kind of hard to wrap your head around. Your body filters about 180 liters. That's nearly 50 gallons of blood every single day. That's enough to fill a pretty big bathtub. So how on earth does it manage a task that huge without you even thinking about it? Well, that's the incredible process we're about to unpack.
To really get what our urinary system does, we need to zoom out for a second and look at the big picture. And that's excretion. You see, every single one of your cells is like a tiny factory. And what do factories produce? Waste. All that metabolic trash has to go somewhere.
Now, your body has a whole team on this cleanup job. Your lungs are breathing out CO2. Your skin sweats out waste. Your liver is a powerhouse, breaking down toxins and creating urea. And, of course, the digestive system handles solid waste. But here's the thing. All of these guys are multitaskers. Today, we're focusing on the specialist.
And that's the real kicker. Unlike those other systems, the urinary system has one and only one primary mission: to be a dedicated, high-performance purification plant that filters waste products directly out of your bloodstream. That's its whole gig. So let's pop the hood and map this system out, shall we? We're going to meet the main players and trace the exact path that waste takes on its one-way street out of your body.
It's actually a really logical flow. First, you have the kidneys. They're the factories where urine gets made. Then, the ureters act like little pipelines, transporting the urine away. The bladder is the holding tank. And finally, the urethra is the exit ramp. Simple, efficient, and direct.
Okay, now for the really cool part. We're going to zoom way in. We're going inside the factory itself, peeling back the layers of the kidney to find the microscopic machinery that does all the real heavy lifting. So, if we look at a cross-section of a kidney, you can see it's not just one solid thing. It's got two main zones. That outer, lighter-colored layer, that's called the cortex. And the darker, fan-shaped structures deeper inside make up what's called the medulla. This two-part design is absolutely key to how it works.
And this is where the real magic happens. Tucked away inside those zones are over 1 million microscopic units called nephrons. As you can see here, these are the true workhorses of the system. These are the tiny individual filtration stations inside the kidney factory. All right, we've arrived at the very heart of the operation. We're going to break down exactly how a single tiny nephron takes in blood and purifies it in 3 distinct and, frankly, brilliant steps. So here they are, the 3 stages. First up is ultrafiltration, which is basically a high-pressure filter. Second, there's a sorting process called reabsorption and secretion, where we rescue the good stuff and toss out more trash. And third, concentration, a final fine-tuning step. So let's get into step 1. Step 1, ultrafiltration. The idea is actually pretty simple. Imagine a high-tech colander in your kitchen, but it's operating under some serious pressure. Blood enters this tiny, tangled ball of capillaries called the glomerulus, and the pressure is so high it literally forces the liquid part of the blood and all the small stuff dissolved in it right through a microscopic filter. So what gets through? Well, you've got water, glucose, amino acids, urea, ions, all the small stuff. And what stays behind in the blood? All the big things, your red and white blood cells, platelets, and large proteins. What's really cool is that the filter itself has a negative charge, which means it actually pushes away other negatively charged molecules, even small ones, to keep them in the blood. Pretty smart, huh? But hang on a second. That colander just threw out a ton of useful things, like all that glucose and water. Well, step 2 is where the system gets really clever. This is reabsorption. The walls of the nephron's tube actively pull all the good stuff, like glucose, vitamins, and most of the water, back into the blood. And at the same time, it actively secretes any leftover waste, like drug metabolites, from the blood into the tube. It's like sorting the recycling. And finally, we have step 3. The fluid at this point is almost urine, but the body makes one last adjustment based on what it needs. Depending on how hydrated you are, hormones like ADH, or anti-diuretic hormone, tell the nephron exactly how much water to reclaim. If you just drink a lot of water, less is reabsorbed and your urine is pretty dilute. If you're dehydrated, your body pulls back as much water as it possibly can, making the urine much more concentrated. Now take a look at this number, less than 1%. Let that sink in for a minute. Of everything that was initially forced through that filter, all the water, all the glucose, all the salts, less than 1% of it actually leaves your body as urine. Over 99% is meticulously reabsorbed and put back into your system. That is just a staggering, incredible level of efficiency, and it's happening inside you right this very moment.
So the urine has been perfectly crafted. Now we move on to the final leg of its journey, how it's stored and ultimately how you decide when it gets released.
The urine slowly trickles down those ureter tubes into the bladder. And the bladder is basically just a muscular, super stretchy bag. Its walls are folded up, which allows it to expand a whole lot, acting as a reservoir to hold urine until you're ready. Now, there are some key anatomical differences here between the sexes. The female urethra is much, much shorter, only about 3 to 4 centimeters, compared to around 20 centimeters in males. The female bladder is also a little bit smaller because it needs to make room for the uterus, which can sometimes mean a more frequent need to urinate. So how do you actually control this? It's this fascinating two-part system. When the bladder starts to stretch, it sends a signal to your brain. This causes an internal sphincter muscle to open up automatically. That's the, uh-oh, I gotta go feeling. But you also have an external sphincter that is under your conscious, voluntary control. You decide when to release it. Well, up to a point. Once you get to about half a liter, that voluntary control starts to get pretty tough to maintain.
So there you have it, a journey from a huge volume of blood down to a tiny amount of waste, all orchestrated by millions of microscopic filters working in perfect harmony. It's a silent, self-regulating system that is absolutely essential for keeping you alive. And it kind of makes you wonder, doesn't it? What other incredible, invisible systems are working for you right this very moment?